Example 5. So we have two cars. If I use the letter T to represent the time for the first car, the second car is 3 seconds behind, 3 seconds later. So I need to use T minus 3 for the second car. So as an example, if on the stopwatch for the first car, if we're recording 5 seconds, then the second car will be 5 minus 3. It will be traveling for 2 seconds. So the first car is here. I need to work out its distance or displacement, initial velocity. I have the acceleration, and because it's braking and slowing down, it's negative. This word here is deceleration, so we need to put a minus in front of this value here when we write down the acceleration. And then we're just using T for the time. And for the second car, again, we want to work out the distance it travels, or displacement, and it's traveling at a constant speed, so there's no acceleration, and this time we're using T minus 3 for its time because it's 3 seconds behind the other one. So a formula that we can use is this, from the Subat formulae, and for the first car the distance travelled is this. For the second car the distance travelled is this. And because we're multiplying by 0, this part of the formula is 0. So the distance between the two cars, if we do S1 minus S2 and just substitute in from here and then expand brackets, collect like terms, we get. So we have the formula that we were trying to show. The cars meet when the distance between them is 0, so we have to solve this equation. So the cars meet after 10.5 seconds. This is a negative value for time we discard. To work out the distance from O, we can use either of these two formulae. This is the easier one. We substitute numbers in. We should actually use a more accurate figure for T rather than 10.5. That's a rounded value. So this is a more accurate value here. And rounding to 3 significant figures gives 189 meters.